Hello and welcome everyone to today's workshop, Oracle NoSQL powers video on-demand applications. Thank you for joining us. My name is Tara Van Cleve and I am a marketing event manager for the developer initiative here at Oracle. Today, we're excited to work with data representing the current activity of customers using a video on-demand streaming application, and to walk you through the steps to create tables in Oracle NoSQL Database Cloud Service, load data into the database, and perform basic queries. We'll also be recording the session, so if you'd like to try the workshop out at your own pace after the event, we'll be sending the replay out via the same email that you registered with for today's event. So if you have any questions during the workshop, please drop them in the Zoom chat and Zoom Q&A areas, and we'll be ready to help answer them there. We've also set up a channel in our developer public Slack called Oracle NoSQL that you can access at the QR code here or at bit.ly/odevrel_Slack. This channel will be remaining open after the event, so you can contact us directly there, and we'll also be sharing resources and the replay there as well. So today's workshop will be presented by Dario Vega, Principal Member of Technical Staff for Oracle NoSQL, and Michael Bray, Director for Oracle NoSQL. But before I hand it over to Dario, here is the lab guide that we will be following today. So let me just leave this up for a moment. All right, so without further ado, I will hand it over to Dario.
So hello, everyone. My name is Dario. So I am working in the NoSQL team. Currently, I am located in Paris. So you have here the two cloud regions that we have in France. So Paris and Marseille. Okay, and we will execute this live lab that we prepare. So this live lab is a tutorial. Okay, this tutorial is based on a demo. Here you have the architecture of our demo. Okay, so we are using NoSQL, we are using Kubernetes, we are using API Gateway. Then I will explain a little bit what is the geosteering. And this demo is actually running. Okay, so we will execute the demo. Okay, so as you can see here, we have the demo. So I will execute this later with you. In fact, the main idea is in the lab, we will create some tables, we will deploy an application, and the application that we are deploying is the same application that we have in our demo. Okay, so the main idea is at the end, we will have the same results that we have in the demo. This lab was created for architects and then also for DevOps people, for DevOpsSec people, in fact. But for this workshop, we decided to do a real focus on development side of this live lab. This is why I will not execute the live lab following this outline. So in this case, for example, in my environment, I already prepared the environment. Then we will start with create tables and load tables. Then we will go to explore data runs query. And then we will back to see the application that I developed, the application that I prepared for you. And when we will be here, I will show you that we can do some, when I develop this, so for example, when I am testing, I am using a tool that we call the Cloud Shell. That is a web browse terminal. So that is just a Linux box. So the main idea is we will test the application from here, and then in your side, you can use another tool that we have that we call container instance. So that is another way to deploy a container application. Okay, it is, for example, useful when you don't need the orchestration of a Kubernetes application, but you don't want to, for example, create a VM and deploy in a VM. That is another case. So just for your information, that is my first version. In the second version, you will have a lab 6 and a lab 7 explaining how to deploy using Kubernetes and how to deploy using virtual machines. So just before to start, a little explication about geosteering. So as you can see here, that is an application that we want to deploy in multiple places of the world. So the main idea is by using geosteering, you will use a unique URL and you will redirect it to the good data center. For example, if you are in US, you will redirect it to San Jose or Ashburn or Phoenix. And if you are, for example, in my case, you will redirect it to Paris data center. But if you are, for example, in Japan, you will redirect of the data center in Japan, on Australia, etc., etc. Okay, so let me start with our demo. So the first thing that we will do is we will create a table, okay? I will explain you what does mean a table, okay? Because we are in the NoSQL world, but we are using a term from the relational world. So that is what we call a table. So just let me show you how it is working. So the first thing that we will do is we will go to the console and we will go to databases and then to Oracle NoSQL Database. So the first thing is, as you can see here, the first thing that we will create a table. It means that you don't need to do anything. So as you can see here, you don't need to create a cluster. You don't need to create a database. Everything is ready for you. Okay, so the only thing that you need is create a table, and behind the scenes, we are doing everything for you. This is why we call that is a full managed service. It means, for example, here we are in Ashburn. In Ashburn, we have 3 availabilities domains. So we have 3 data centers. So every time that you are writing a row or a document in our tables, you are writing in the 3 data centers. And when you are reading from one of those data centers. You don't need to know how many servers we are deploying. So that is something that we are doing for you. Okay, so everything that you need to do when you create a table is provide the description of the table and tell us what you are expecting from performance point of view. Okay, so how many read units you want to do, how many write units you want to do, and what is the space, this storage space. Okay, you have also the possibility to ask on demand. So in this case, you don't need to do a capacity planning to know how many reads or how many writes I need. You just need to say, I want to have on-demand capacity, and the bill will do on the real consumption that you have. So that is I can say that is a real pay-per use. Okay. So in this case, I prepare. So when we are saying what is a table, so a table, I will provide you a definition. A table is an unordered collection of record items, all of which have the same record type. We call the record type the table schema. What exactly means this? When you are creating a table, so you have a schema, and you can decide if this schema is schemaless. So in this case, we will do a schema on read, or you can decide if you can do a schema on write. So in this case, we will have what we call fixed schema, and you can merge. You can say, for example, I would like to have some fields that are fixed and other fields that are completely free, okay? And in the documentation, that is the most important point that when we are discussing about Oracle NoSQL Database, so our focus is in the table modeling, okay? And here you have what are the trade-offs when I can decide that use a flexible schema or when I can decide to use a fixed schema. So I prepare some tables to show you what exactly means this. So the first thing, I just want to show you what is a full fixed schema table. So I will execute this. And as you can see here, we have columns, but in this case, the columns are arrays. Okay, so this is why I am saying, don't think as a traditional table. You can think like a collection. You can think like documents. For example, if you don't want to see this as a column, you can just say, okay, so here I am doing a schema and read. I just want to say, okay, in this case, I want to see this as a document. Okay, so this is why we are saying Oracle NoSQL Database allows you to have key value and also allows you to have a document. So we are both models. And I will show you what it means for us. We are saying that we are simply multi-model. It means that we can deploy an application using a model. So for example, fixed schema, and then you can decide to execute the same application using a schemaless model. Okay, so just let me show you what exactly means a table. So as you can see here, we are saying that we have an ID that's in integer, address that is a record, and in this record I have a city, and then I have a door number and a street, a zip, etc. So just the second step that we will do is we will deploy the table for the application. So in this case, we have multiple ways to execute, to create a table. So one of them is we can use what we call OCI CLI. As you can see here, I am showing an example. We can create a table using a REST call. Okay, so I'm just saying where I want to deploy my table, what is my table, and what is the table limit for my table. Okay, the table limit is just the max read units, the write units, and the storage that I have. I can also create the table using Terraform. So as you can see here, we have a Terraform script. At the end of the day, we are providing the same thing. So currently, the important point here is we are not deploying cluster, we are deploying tables. The clusters are already deployed, and we are managing, that is fully managed by Oracle. Just let me click here, and go to the instruction. So we will execute the instruction. And as I told you, I will use the Cloud Shell. Cloud Shell is a box, a Linux box. So here I have the Linux box. And we have also a tool that we call Code Editor. So as you can see here, I have my IDE with our application. The deployment of the application is happening in Prepare Your Environment. So here we will deploy what we call a schema-less application. So I just want to say, okay, I want a primary key. That is mandatory. All the table must to have a primary key, but you can decide if this primary key is single column or multi-column. And you can decide, for example, if you don't want to manage the key, you can say to the system, please generate a value for me. It could be identity or it could be an UUID. So just let me execute. So here we will execute the command. As you can see here, we will execute the DDL command and we will provide our limits. Okay, the table is created. And the table that we will use is here. That is the table stream act. If you execute, currently I have some data, okay, but we will add some data to this table. So as you can see here, if you remember, I say I will start with 4. It means that I will manage myself the first 3 records. So just let me continue here. So currently we have multiple APIs, and in this case, I will use the SQL API. And then I will show you, that is SQL, but it is a dialect of SQL, okay? That is a mix between SQL and jQueries, okay? So we will execute, so we will add a value here. And as you can see here, I am saying, please return the value that you insert, and we will have the data. Okay, so the data currently is with the information about the customer, and we have the shows that we are looking for. And as you can see here, I am not providing, when I am inserting, I am not providing characters, I am providing a JSON document. In fact, it depends on the language that you are. For example, if you are in Python, that is one of my preferred language, you will have dicts. If you are in Node.js, you will have objects from Node.js. And if you are in Java, you will have something that we call a mat value. That is the same thing for Go, etc. Well, the next step is we will execute to insert a new row. Okay. And I will do a small modification here. So instead of doing this, I will say, okay, we have the possibility to manage what we call TTL. So I will say this row will expire automatically after 3 days. And as I told you, we are talking about rows, but in fact, we are talking about records because we have some other attributes that are specifically to each row. So for example, the modification time, the expiration time, and the version. The version, we are using this when we are using the API key, okay? And in this case, we are using an API, and for example, we can say, okay, I want to retrieve the version, and when I am putting again the data, I can say, okay, I will put the data only if it is the same version. But just let me execute this. So what's happening? Okay, I just forget to do a small change here. So here we execute. So in this case, I have Tim Gigerman in USA, okay? And here I have the information. So that is the date of the modification. In this case, when I insert the row, and here I have the expiration date. So this row will automatically be deleted in 3 days, okay? As you can see here, I will also add a new row, okay? And I will show you another way to work with this. So I will execute this. So in this case, I am inserting the row 3, but I have another API. And in this API, in fact, we are using CRUD API. So we have create, we have read, we have update, and we have delete. For example, let me change here. So I am updating the row. So in this case, I am not using SQL. So for me, when I am using insert, when I am using update, most of the time I am using the CRD API. For me, it is not interesting to use SQL, but I will show you some things that why it is interesting to use SQL when we are inserting data. Okay, so for example, in this case, as you can see here, I am returning all the documents. But for example, so for example, I can say, instead of returning the row that I am inserting, I will create my document. So just let me show you what is the document that I want to return. It's a summary. And in this summary, I am providing some information in French, some information in Spanish, some information in English. And I am just interested in know how many shows I am inserting. Again, I forgot the alias. So I execute, and as you can see here, I have my summary. Okay. And just to finish, I will copy this data and I will go to in another table that I call stream at fixed. So if we execute, currently I have 2 data, so I will take the first one, in fact. I just need to change the name of the table. And I will execute. So as you can see here, I am executing the same command and I am inserting on row. So what is the difference? So if you go to the table, as you can see here, I don't have an info that is a JSON generic. So when I am using JSON, I am using schema on read. In this case, I decide to use schema on write. So I am saying the info is a record with a first name, with a last name, with a country. Which shows, the show is an array of records. And for example, I have the show ID, I have the show name, I have the genres, that is an array. And I can continue to do this, but for example, for the series info, I decide to say, okay, the series info, it will be not at write, but at read. Okay, so just let me show you. That is exactly the same array. And here we have the series info. The series info is also an array, and we have multiple data inside. So I can decide that I can do a fixed schema, a full fixed schema, or I can decide that I can do full schema-less, or I can decide to do in the middle of them, okay? So again, you can read in the documentation what are the trade-offs to choose one or choose another one, okay? Then I create another version of the table, and here we have the same 3 rows. We have with Oracle NoSQL the possibility to create what we call replicas. Okay, so in this case, I will create a replica, and I will create a replica in another region. So for example, I will create a replica in the region of London, okay? And I will add a replica to my table. That is what we call a global active table. So in fact, as you can see here, I am creating the table in the region of London. So it is completely, we will have the same data in the region of Frankfurt and in the region of London. So just let me change a little bit. Let me update here. We will say John, instead of John, we will say Johnny. So I will update here. So as you can see here, now we have Johnny here in London. And if we will go again to Frankfurt, and I query the same table for the record one, we have Johnny, okay? So that is one of the things that we are using when we are deploying this application. So as I told you, I can decide to have distinct tables, or I can decide that I can have the same table in Ashbourne, the same table in, for example, in San Jose, and the same table in Paris. So when you are updating in one region, you can create what we call a global active table. So the data are propagated to the other regions. And as you can see here, it is completely fully managed. You just want to say where you want to replicate the data in which region, okay? And here, as you can see here, you can change the throughput for the regions. For example, if I am expecting to have more users in, for example, in Paris, I can provide more capacity for Paris. If I am expecting to have less users, for example, less activity in London, I can reduce the capacity for London. Okay, so that is all that I want to show you today about the table. So we see that we are in a fully managed service. So it means that you are not creating clusters, you are not creating databases. We are managing all of this for you. Then we create the table, and in this case, we created the same table using schema-less or using fixed schema. Okay, so we are able to have the same application running using a schema on write or a schema on read. Of course, there are some trade-offs when you decide to use one of them. But for example, when I start to, I will show you, we will create some indexes, we will execute some queries. In fact, the same queries are the same if you are running in schema-less or if you are running on fixed schema. So just let me execute this live lab with you. And in this live lab, we will run some queries, okay? So the first thing is if you go to my table, so my original table is stream app. I already create some indexes, so I just want to show you how to create indexes using Oracle NoSQL Database. So I think that I keep the last one, so I will create this index. Okay, and I will choose the column. Remember, my column is a JSON, okay, in this case. And I will say, I would like to index the genre. Remember that the show is an array. So I can say that is a multi-value index, okay? think that first is country. String. Then I can create. Okay, so we are creating an index. Of course, if we have replicate, in the replicate, you will have the same structure that you have in all the regions. For example, if you are creating an index here in Frankfurt, it will be automatically replicated to all the replicas that you have. Okay, so it is done. So now we can execute our queries. Okay, so here that is just a reminder of the indexes that we are creating. So the first thing, I will execute some queries and I will explain you what I am saying that we have. When you want to query your data, you can use SQL, but that is a dialect of SQL, okay? In the NoSQL database, now it is very common to have SQL. For example, in DynamoDB, we have partial QL. In Cassandra, we have SQL, that others call this SQL++, others call this KQL. When I was working, we have HQL. So, but the important thing is it is not a standard SQL. So that is something that we created specifically for Oracle NoSQL. And you will see that it is a mix of SQL and jQueries. So here, what we are doing is we are saying, okay, I want to go to the info column in the country. I want the data for USA. And if you remember, I have multiple show IDs. So I just want to go here. So I have multiple show IDs and I have a show ID. So in this case, I am looking for someone in USA with the show ID 16, okay? That is something that I didn't show, but I create an index that is saying that this is unique inside of this record. Okay, so I cannot have duplicators for the show ID.
All right, we're about halfway through now.
Okay, we are good. Thank you. Okay, and we can see our execution plan. And as you can see here, we have this index, and this index is covering this condition. So info country equals USA. And as you can see here, we have an array, and inside the array, we are looking for the show ID section. Okay. So that is my first query. And then we have another one that is more interesting, at least for me. And as you can see here, so just let me show you here, I am using an operator that I call any. So in this case, I am saying that it is returning multiple rows, and I just looking for the value 60. And here I will change a little bit, and I use something that is more jQuery. So for example, here I am saying, okay, it could return multiple rows, so I am not interested in a value. I just want to know if it exists a show with the show ID equals 60. Okay, so it is exactly the same query, but at the end, we will use the same execution plan. So just let's continue with this. Currently, here we prepare another query that is more interesting. Okay, so here, as you can see, we are going to the show 16, and then we are going in the series info. We are going to the episode, and I am interested for the episode where the date is greater than this value. So in this case, I will execute this, and I will have the information. Okay, so in this case, we are interested in the show 16, so it is one. Then we are going in series info, and we have an episode, and here we have two values. and all of those values are greater than this one, but we have an exist. So this is why we are returning only one row. Let's see the execution plan. So in this execution plan, we are using this in order to have the quality, and then we are applying this condition. Continue. Here I am doing something that seems to do the same thing, but as you can see here, that is an error. So this is why it's an incorrect way of writing the above query. Because here we are saying, okay, I am interested to the show ID. So imagine that it is not unique. And then we are saying we want to have an episode date greater than this value. It means that, for example, I can have the show ID 12. So only for the show ID 12, that is true. So in here, I am not doing the correlation. I am not saying that I am interested to go inside this show, because here I am saying I am interested to a show, but then I am saying, okay, I will execute a where clause on the other shows. Okay, so it could be true even we are not providing the good query. Okay, so that is interesting to see the difference between I am going in a record, I am selecting inside on an array, and then I am continuing in the same array to see if I have another clause where. Okay, here we are not doing this. Oh, here we are doing another query. Okay, so I will execute this one. So that is a similar query. But when you look the execution plan, in this case, maybe I want to use another index that are more accurate because we have the date. So in this case, when you are not using the good index, we have the possibility to say, okay, we want to do another index. And the thing that changed is that now we are using another, I think that I did an error when I create the table, but that is the way to say to the optimizer, okay, I want to use another index. As you can see here, we are using a single table. So our optimizer is a rule based. Okay, so we are applying some rules. And that is the way that we are saying that we have to say to the optimizer, okay, the rules that you are applying are not good. We want to use another index. Let me execute this query. And this one, it is really interesting because as you can see, we can do selections. Okay, for example, here I am saying inside of this show, I want to see if something exists in French and then in Danish, and I can see if something episode exists between this date and this date. So as you can see here in my nested object, I am able to do query inside of each of the array without unnesting the table. Okay, so in this case, when I will execute, I will have 2. So as you can see here, it is very powerful. And then we can continue. So here we are doing very powerful things. For example, here we are doing a sum, but we are doing a sum inside of every single element. Okay, and we are summing if a condition is good for the show. So here we are only summing it for the show ID 16, and we are summing the minute watched. Okay, and we are doing some transformation in order to have the show name, the season number, the episode ID, the date wedge, because we know that we have only show for this one. Okay, so let me execute this. And as you can see here, we have the episode here. Fortunately, I don't put, so we have the different information that we want from our record. So in this way, we can also say that that is also a schema on read. So we are defining what we want as a result by providing the projection that we want to apply to the data. Okay. Let me execute another one, this one. So in this one, I am using the size, that is the size of the array. So here I have multiple seasons. So I am interested to know what are the people that had already looked all the season of the series. Okay, so as you can see here, we can do extremely powerful transformation. Okay, so you will have time to read and execute the clause. We are providing all the details on what we are doing in every single query. But the main idea is just to show you what powerful is this SQL, because as you can see, we are merging jQuery and SQL state. Okay, but we can also unnest. What means unnest? So for example, we have one row. So in this case, we have one row. And we can say, okay, instead of having an array, I want to have a line by the item inside the array. So as you can see here, that is the primary key. So we have one, the value one. It means that currently we are looking what are the values here, and we are saying, okay, we want to have a row for each of the rows that we have that we have in this record. Okay. And what it is interesting, because currently we can do, for example, reports. So this is one of the reports that I am doing in my application. So in this case, I will execute this one. And as you can see here, I am just counting how many people are looking for this show. Okay, so this is the number of the show. And here I have how many people are looking this show. But we can do also other interesting SQL for analysis. Okay. And here I will have again the show ID, but this time instead of saying the count, I just want to see how many minutes the people are looking this show. Okay. Again, we can continue. And we have this, and in this case, I am interested for the sum inside the minute watched, okay, for a specific show. Okay, so that is a little bit different. Again, so the main idea just here is just to show you how powerful you can do queries with Oracle NoSQL, and I will stop for here for this step. Now I will show you the application that we create, okay? So the application that we create, so we create a GraphQL application. So for example, here I am executing one of my queries. And as you can see here, I am answering what are the data that I have here. Currently, I have only 3. So I have Aniket, I have John. And then I can show, for example, and I can say, okay, I'm interested in have more information. I am interested in have the date, the episode, and let me show, for example, the type. And I can execute this. And of course, my API, so we have a schema for this API, and here you have all the description of this API query. So as you can see here, I'm just defining what is a stream. And a stream is an int with an info. The info is the first name, the last name, the countries, the show is inside. So currently here I am describing all the information that I am putting in the database. Another way to suit this is using Postman. So in this case, I am executing the same query, but using using Postman. So we have the same query. And the interesting thing here, the code, we can execute this using core. Okay. Again, so just let me execute another query because we have time. So we have query, but we have also mutation. So I can insert a new customer, and then I can update this customer in order to insert a new show. So in this case, we are saying, okay, this customer is doing this show. Okay. So now I finished the demo here. I just want to come here again. So just let me explain you what we did this application and what exactly we are trying to do. In Oracle, we have multiple services about streaming. So for example, we have a service that we call streaming, OCI streaming. So you have the possibility to do and secure and scalable distribution on media stream using a content delivery network. So that is one of the services that we are deploying. Okay, you have also the possibility to process large media video requiring large compute shares for timely and efficient processing. Okay, we can also the possibility to do transcoding and packaging a source video into a format for a suitable streaming service. Okay, and we can also innovate with AI services. Okay, just for information, some of these services, for example, the service AI service is using Oracle NoSQL. We have another service using catalog. So the main idea of this demo is we will create a microservice just in the activity tracking. So as you can see here, we are currently the activity of the customer using the video on demand application, and we are doing some reports. Okay, I forgot to show you the report. Yes, we have time to do it. Okay, just let me go here again. So we have a specific data stream. So I can say that is what our users are using. For example, when you are looking at video, so every time that you are looking at video behind the scene, we are adding an episode. We are tracking what you are doing. For example, if you start to see a video and you decide to stop and come later, that is what we are storing in this application. Okay. But we have also the possibility to say, okay, I want to execute some reports. And for example, that is one of the queries that we execute. Just let me delete this. And we can execute this query. So we can do, oh, sorry. Oh, no, I will not execute here. I will say USA. And here we have the people that are watching in USA. So we have 2 people looking for the show ID 2, one for the show ID 16, and another one for the show ID 30. Okay, so that is the main idea of this GraphQL application. Okay, so just let me go to this and let us review the code. So as you can see here, we will go to the code. And for this, again, we will use the code editors. The first thing that I want to show you is the code of this small application. So we are using, in this case, I decide to use Apollo GraphQL. And here you have our package. That is a Node.js application. We can we can create the table using the console. We can create the table using OCI. We can create the table using REST call. We can create using Terraform, but we can also create the table inside your application. Okay, as you can see here, you are providing the same parameters, and we are creating the table, and then we can create some indexes. And then we will do the connection, and that is the interesting thing here, okay? Because we have multiple ways to address the security, okay? For example, in my case, when I am deploying the application here, I will use what we call instance principle. So in this case, we will create a dynamic group, and we will say, okay, just let me show you the dynamic group. So in this group, I am saying I create a dynamic group, and all resources that the compute instance in this compartment are in the same group. And then I can say to this group, I will allow to manage the NoSQL family. So there is multiple ways to connect. One is I am connected here, so I am a user. If I have the good privilege, so I can run this application. Another one is I am a service, so I am also a fully managed service like compute container instance. So in this case, I don't need to create password. I don't need to rotate API keys. I don't need to rotate password. I don't need to put the password in a vault. I am just saying, okay, those resources are in a group, and this group have the privilege to manage this the NoSQL tables in this compartment. We can do very powerful things here in order to do the matching rule. And the interesting thing is, as you can see here, we can use, the only thing that we can change is the way to do the connection. So for example, here is when I am saying I am executing from a VM, or I am executing, for example, for a pull node in Kubernetes. Or I can say, okay, I will use another way to do the connection that we call delegation token. So that is when I am in the Cloud Shell. Okay. Oops, sorry. When I am in the Cloud Shell, I have this variable. So as you can see here, I have a delegation token. So I will use this delegation token in order to connect. So in this case, I don't need to provide the password for this user. And in fact, I can create what we call an API gateway. And for an API gateway, we need to provide the key, the private key and the public key. In this case, I don't need to create the private or the public key. I just need to use this another way to do the connection. And we have the same thing for what we call resource principle. Resource principle, for example, we are using this when we are using the service computed, the container instance service, or when we are using other services like functions or multiple services that we are integrated with. And here, as you can see here, I can say also, I can connect to an on-premise cluster. What I mean is the same application I can run here in the cloud using this service. That is a managed service, but I can also decide to execute the same application, for example, in my on-premise data center. Okay. The only difference is in this case, I need to manage the cluster. Okay, because we don't have the fully managed service in on-premise. But you can also decide, for example, to execute this application in another cloud service. So the only thing that you need to do is create the cluster in the other cloud service, and then you will use exactly the same application. The only things that is changing is the way to do the connection. And again, then you will have exactly the same code. So for example, when I am asking for all the stream, I am executing this query. In this case, I am using a limit. Here, I am creating a query looking for the last name. Okay. Here is my first report. So in this case, we are executing this query. Okay. And remember that we are providing a parameter. Okay. The interesting thing here, as you can see here, every single query returns an object for Node.js. If you are in Python, it will return a dictionary. Okay. Here we have another query. And as I told you, for example, when we are looking for a stream using the ID, in this case, I decide not to use this, but I decide to use our API CRU dish. Okay, so I call this the key value API. So in this case, I am saying, okay, instead of using SQL, I just want to ask for the value with this ID. And when I am creating, I am just saying, okay, I am just putting the value in the parameter. So here you have all the information from this customer, and you are just saying, okay, I just want to put this. In this case, I am using put if absent, okay? And as you can see here, I am retrieving what is the new value for this. For update, I decide to do differently because it is really interesting when we are using the update clause is that I have multiple possibilities. For example, in this case, I am saying to the array shows, I will add a new JSON document, okay? So instead of using a get in order to have all the JSON document, modify my JSON document. In this case, I am saying it is not a JSON document. It is my variable, my object variable. Modify on my and put it again. In this case, for example, I need to think, oh, what happened if I am reading, and when I am reading, someone else are modifying the row. So in this case, I need to do what we need to use the version in order to do, in order to be sure that what I am reading, I am putting. In this case, by using the update, I am sure that I am modifying the current version of the row. And again, when we are using delete, I am not using SQL. I am just calling the delete operation. And then that is a standard GraphQL application. Okay. So just let me deploy the application just to finish. So we will deploy. That is a standard my application is ready to receive in localhost. Then I will execute, and we will have the same result that we have when we are using the application, when we are using my dev. Okay. We can execute another query. Okay, for example, this one. And here I am asking for the user ID one. So I have that is my query that I decide to execute. Okay. Again, then you can continue to execute the lab. So here, for example, we are loading the data, and that's all the data that I showed you. Okay. And finally, we can deploy also using using the container instance. So here you have the instructions to create a container instance. So it's here. So for example, what is a container instance? So here I am deploying, I am choosing where I want to deploy this. And then I'm just providing where is my registry, where is my container image, and I am just publishing. Then I will, here you have the parameters. So here I am saying that I will use resource principal. So if you remember, when I am doing the connection, I am saying, okay, here I will use resource principal. You continue and you click and you have a public IP address, and then we will execute exactly the same query, but using, instead of using localhost, we will use the public API for this. Just to finish, just let me show you how I am deploying this application when I am using a Kubernetes. So in order to do this, here. So as you can see here, I am using GitHub Actions. So inside GitHub Actions, so I create this deployment. So I am saying the first thing that I will execute is all the commands that we execute previously to create the table. Okay, so again, we are executing exactly the same commands that we execute together. And then, as you can see here, we are saying create the table. Of course, if the table exists, we are just let me show you in the command, we are saying create if not exist. Okay, so we will not have errors. If the table exists, we continue. And then I just want to execute this command, so the Kubernetes application, in order to deploy my application. So just let me show you the application. So here we are deploying using a load balancer. And the only thing that we are saying is, okay, I will use this container image. And again, we are just changing the parameters in order to do the connection. In my case, it is Paris, and I am using instance principal. Okay, I think that I finished for today. We have questions.
All right. Well, if there are no questions at this time, we will hop on over to the Slack to see if there are any questions there. But I'd like to thank everyone so much for joining us here today, and we hope to see you at the next one.